Hello students, welcome to episode 4 of DECODE NCERT. So today we are going to discuss the chapter Electrochemistry. So as I always told you, DECODE NCERT is not about teaching the whole chapter. In this I will tell you which all sections of the chapter are very important, what all questions can be asked from that. So you need to highlight those things and revise only those parts from the book, and you can save your time by not reading the whole book line by line and word, right? So yes students, so now before starting I want to request all of you to sit with your NCERT book with a highlighter, with a pen, so that you can write pen or pencil where you can write down the questions aside the text. Okay, so let us quickly start now. Electrochemistry, so you can see like this in your chapter. Let me just zoom it. I hope it is visible. 1 second. Yes, I hope now it is visible. So here in the introduction part we don't have anything to study. Okay, now coming to this part. Okay, so I will zoom here a bit. Okay, I hope it is clearly visible to all of you. Okay, so here you can see the voltage of galvanic cell is given 1.1 volt. So it can be asked as an MCQ. Highlight this one. Then what is galvanic cell, that you should know, where the concentration of Zn2 plus and Cu2 plus is taken unity. Okay, next you have that this question has been asked many times. The Daniell cell is 1.1 volt, right? So what will happen if the external voltage is less than 1.1, equal to 1.1 and more than 1.1? So there is 3 cases. Here you can read this part. Now once we move forward, okay, so once you go forward, let us move. So here all diagrams and all, no need to do anything. Go to the second part. Here what is a galvanic cell? The definition of galvanic cell is given here, that you should know. Okay, okay. Next we have, this is there in this device, the Gibbs energy of the spontaneous redox reaction is converted into electrical work. Okay, this line is again very important. Now these all things we have studied in our normal theory questions. Then what is half cell, what is redox couples, then you have that copper reaction, the reduction half is the copper and the oxidation half is zinc. Then these are all things that you should just read, nothing questions can be framed from here. So you need to read this part in detail. Okay, now if I go forward, here also we don't have anything to study. Next we have something called as electrode potential, the definition of electrode potential and the definition of standard electrode potential. These two are very important. Next we have where oxidation takes place, where cathode reduction takes place. I think this all of you know. And then we have the potential difference between the two electrodes, and as soon as the this is about something called as the potential difference between the two electrodes, and as soon as the switch is on, the position the electrons flow from negative electrode to positive electrode. Okay, so 1 second. Okay, so we will go in the next paragraph. So what is this one? 2 important definitions you have, that is your cell electromotive force, okay, and cell potential. Okay, cell potential, what is the definition? The potential difference between the two electrodes of a galvanic cell is called cell potential, and it is measured in volts. The cell potential is the difference between the electrode potentials of the cathode and anode, and it is called cell motive force of the cell when no current is drawn. Okay, if the difference between the electrode and of the cathode and anode you are measuring when no current is there, then we call it cell EMF. Okay, and cell potential when there is current and you are measuring the difference between the two electrodes. Okay, these two are very important definitions, so please mark it. Next we have, generally by convention, anode is on the left, cathode is on the right. Okay, then we have this formula, E of the cell formula. This I think all of you would have known it because you have done numericals on this one. Next I am just telling you what all things you should read from the book. So now standard hydrogen electrode construction, and this diagram is very important, so please mark this. You need to draw this diagram as well. Okay, next coming to, okay, next if we go forward, we can find here the thing, something. Yes, now something about copper. Okay, so the copper does not dissolve in HCl. This is important. In nitric acid it is oxidized by nitrate ions and not by the hydrogen ions. Okay, so these 2 points are important. Next coming to again here there are something, what are inert electrodes, okay, definition of inert electrodes. So please write a heading here, inert electrodes, okay. I have put highlighted here inert electrodes. I hope all of you can see it. So please mark this inert electrodes, okay, mark this one and learn the definition of inert electrodes, and example also you can write here. Fine, this can be asked as a question. Next, coming to the some very important point, standard electrode potential of fluorine is the highest. So remember, standard electrode potential of fluorine is highest here. Then so that is why fluorine gas is the strongest oxidizing agent, fluorine ion is the weakest reducing agent, lithium has the lowest electrode potential, okay. So fluorine has the highest, lithium has the lowest, indicating that the lithium ion is the weakest oxidizing agent while lithium metal is the most powerful reducing agent, okay. So these are the things: strongest oxidizing, strongest reducing, weakest oxidizing and weakest reducing, okay. Next we have the electrochemical series, the potential decreases, okay. So that is there here. Next we go, so this in-text questions, please all the in-text questions you need to solve, so make sure that you are solving the in-text questions, okay. So I hope this is visible, okay. Now coming to your Nernst equation, okay, Nernst equation is there, so please remember how to write the Nernst equation. This I think all of you will be knowing because we have solved so many questions on Nernst equation, okay. Next, this is the standard reduction potential. You don't need to remember the reduction potential, just you have to remember for hydrogen electrode it is 0, okay. Now here there is something very important that you should be knowing. The negative E0 value means that the redox couple is a stronger reducing agent, okay. So if it is a negative value means it is not undergoing reduction, it is undergoing oxidation and it will behave as a reducing agent, okay. Now if it is a positive value means it is undergoing reduction and will behave as an oxidizing agent or a weaker reducing agent, okay. Now let us move forward. Here we have this Nernst equation. I hope all of you know how to solve Nernst equation. Next, this is very important, that if the copper ion concentration will decrease, okay, so it increases, E of the cell will increase with the increase in the concentration. If Cu2 plus increases, E of the cell will increase, and if Zn2 plus will decrease, then E of the cell will decrease, okay. So that you should, sorry, it increases with the increase in concentration of Cu2 plus and decrease in the concentration of Zn2 plus. So these are very important. So from here also questions can be asked. So you should be knowing this. Then we have Nernst equation for different species. The examples are given. Should be remembering when there is coefficient, that has to be taken as power here, okay. Next, if we move towards next, this in-text question, you have to solve it, okay. All the in-text questions you need to solve it, okay. Next, coming equilibrium constant here. So in equilibrium constant we have to remember this equation, okay. Please highlight this equation. E0 of the cell is equal to 2.303 R0 by NF log Kc, and then one more equation I have here. You have to solve this question also, okay, examples of questions, okay. Next, coming to something called as electrochemical cell and Gibbs energy, okay. So now what is this? Electrical work, define electrical work, is the work done in 1 second is equal to electrical potential multiplied by the total charge. Now if we want to obtain the maximum work from a galvanic cell, then charge has to be passed reversibly. The reversible work done by a galvanic cell is equal to the decrease in Gibbs free energy, and therefore if the EMF of the cell is E and NF is the amount of charge passed, then delta GR is the Gibbs free energy of the reaction. This equation you have to remember, okay. Next, we have this formula, this two formulas, please highlight it. This is also very important formula, please highlight it, okay. It's already there in the first part. Then do this in-text question, okay. And okay, now if we move forward, so coming to conductance, okay, here there are different terms and you should be knowing their meaning. So first is the term is resistance, okay. Then you have the term resistivity, so know the definition of resistivity, okay, it is highlighted here, okay. Next you have, sorry, okay, this is resistivity, okay. Then you have conductance formula, okay, the symbol of conductance, then SI unit of conductance, what is conductivity, okay, that is also there. Then you have the SI unit of conductivity, okay. Then these all things are given. Okay, so these all things you have to highlight it. Okay, so just let me wait for you if you have, sorry, 1 second. Okay, fine, please highlight these all things. Okay, done. So these all whatever terms are there, I am telling you that you should be doing. So next, here some values are given, doesn't matter. Here this is very important, that the magnitude of conductivity, okay, the magnitude of conductivity depends on what factors? So depends on the nature of the material, depends on temperature and pressure. So you need to give 3 points, right? Kappa depends on what? 3 points. Okay, it can be a 3-marker question easily. Next, you have conductors, insulators and semiconductors. So what are conductors? Examples are there, metal and their alloys. Then which non-metals can also be conductors? That is carbon black, graphite and some organic polymers. Okay, then you have some insulators like ceramics and glass. Semiconductors, you have silicon, doped silicon, gallium arsenide. Okay, so these are the examples, you have to mark them. Next, we have something called as superconductors. So example you should remember. Superconductors definition is also given in the book: zero resistivity or infinite conductivity. Okay. Now metals and their alloys at very low temperature, 0 to 15 Kelvin, were known to behave as superconductors earlier. Now we have new superconductors like ceramic materials and mixed oxides even at 150 K. Okay. So that is there. Superconductance is important. Next, electrical conductance through metals. Okay, so depends on what factors. Please remember these 3 factors. In the Brahmastra question also, I have given you all the factors, that type of factors, type of questions that can be asked. So remember these 3 factors, very, very important. Okay, I hope this is visible to all of you. Okay, fine. Now let us go forward. Okay, students, wait. Have I zoomed too much? Yeah, I got it. Okay, so electrical conductance factors we saw, right? Now we can see the ionic conductance factor. Okay, so just there are 5 factors in the book. Mark all these 5 factors from ionic conductance. Okay, next, okay, next we have something here, that passage of direct current through ionic solution over a period of time can lead to the change in its composition due to the electrochemical reactions. Okay, next is very important, measurement of ionic conductivity of ionic solution. So this is a very, very important question that is there in your blueprint also. Okay, so what are the problems why we cannot use Wheatstone bridge to measure the ionic conductance? So 2 problems are there, and after the 2 problems, the 2 solutions are also given. So these 4 things you should be knowing: 2 problems of using Wheatstone bridge to measure the conductivity of electrolytic cell, and you also be knowing the 2 solutions for that. The first is your it is not possible to use DC current, so the solution will be to pass AC current, and the second one is a solution cannot be connected to the bridge like a metal wire, and the solution for this is using conductivity cell. Okay, now coming forward, this is the construction of conductivity cell. So 1 minute, let me see if I can use pen here. Okay, so this is your conductivity cell construction. So question can be asked from here. So you should not leave anything from this book which is possible. Okay, so conductivity cell construction, this is the point that you should be writing. Okay, now 1 second. Okay, now if I move forward here, what I'll get? Cell constant definition. Okay, then how the cell constant is determined, that is there, but this is not a very important thing, but you can just go through it. Okay, next we will have here Wheatstone bridge. Okay, so something regarding the Wheatstone bridge is there. So what is there? First of all, let us see. So how to measure? Okay, so this is the point how it is measured. So you do not have to go and read this question, but still I will want all of you to at least read this paragraph. Okay, do not miss this. After everything is done, you can just read this paragraph, and the question like what should be the setup for the measurement of the resistance, okay, of a ionic conductance. So this setup, just go through it. Okay, but I will write at the last. Okay, not very important, but yes, once it is done, just read this paragraph. And here something you should remember, the oscillator cycles you should remember 550 to 5000. Okay, but yeah, this can be asked, and if the question paper is very tough, then this question can be asked, but whatever is there in the book we should be knowing. So this is what, this is regarding how to measure. So you write the question, how to measure the conductivity of, how to measure the resistance of electrolytes or ionic electrolytes. Okay, so regarding that the question is there. Okay, now we will move forward. Here also you can know the unknown resistance. This can be asked as an MCQ here. Okay, so this can be asked as an MCQ. So for, please remember this formula also, this is important. Okay, other all formulas we generally know because that is there in other questions and all. Okay, but here we should know something different. Next, the conductivity of the solution means kappa depends on what factor? It depends on the charge and size. Okay, charge and, one second. Okay, it depends on the charge and size of the ions in which they dissociate. Okay, then they depends on the concentration of the ions, and these are the two things on which the conductivity will depend, right? Next we have here something called as molar conductivity, the formula of molar conductivity kappa by C. Okay, next if you have it is in meter, what should be the formula? Next, if centimeter, what should be the formula? These two formulas are important. Okay, so this is important and this one is important, so mark these two formulas. Okay, now coming to next one, going forward, this is some unit conversions that you should be knowing. Next is you have to solve definitely this in-text questions 2.4, all examples, please do not miss even a single question, solve them. Okay, next is we will go towards, is another question that you need to solve. Okay, here is conductivity and molar conductivity variation. This is very important question. Okay, this is very important question. You should be knowing what should be written for weak electrolyte and for strong electrolyte. Okay, so this is there already explained. I have explained many times in the Brahmastra series also, so you can watch that video and you can read this paragraph to understand it. Okay, next coming to what is the definition of molar conductivity, that is here. Okay, next if we move towards here the graph. Okay, so what is the definition, like how the molar conductivity changes with dilution, that is there. Okay, and next if you see we have something here, the graph. Okay, this graph is very important. Okay, this graph is very important, so please make sure that you learn this graph, like what are the levelings and all. These points and all you can lift, but you should be knowing about the y-axis and the x-axis. Okay, next something we have is limiting molar conductivity, its definition, its unit, okay, its symbol. And then we have strong electrolytes. So this is something very important, this paragraph. Okay, regarding the type of electrolytes, very important, so please learn it, especially what is this A. Okay, what are these electrolytes? Okay, these are very important. What do you mean by 1,1, 2,1 and 2,2 type of electrolytes? Okay, these are very important. Please learn this, understand this paragraph properly. Fine. Next, if we move forward, we are towards the Faraday's law, I hope. One second. Yeah, Kohlrausch law. Okay, so Kohlrausch law, definitely the statement is important. It is a very big statement, so learn it again and again, write and practice again and again so that you can remember this. Okay, next after this we have, so these all things no need. Okay, next we have weak electrolytes. Here what, yeah, so here a question can be arise like why we can't measure the molar conductivity of weak electrolytes. Okay, that this will be the answer. Okay, so you can say therefore lambda naught m cannot be obtained by extrapolation of lambda m to 0 concentration. So question may be asked like lambda naught m cannot be obtained by extrapolation of lambda m to 0 concentration, explain. So these are the points that you need to explain. Okay, similarly if they are asking therefore lambda naught m for weak electrolytes is obtained by using Kohlrausch law of independent migration of ions, explain. Then you have to explain these 2 points. Okay, so for this particular question this is the answer, for this particular question this is the answer. Okay, so make sure that you write this statement, explain, and then write this paragraph as an answer. Write this statement, explain, and from here add to accurately, that is the answer for this one. You can frame it in your own words. Clear? Fine. Next, moving forward, we have like this formula is important, this formula is important, okay. These formulas I am not giving, one second, yeah, so this formula is important, we have, okay, one second, okay, this formula is important and we have this formula important, okay. These two formulas are important. Now coming to next, that is the applications of Kohlrausch law. So applications of Kohlrausch law, you can just read down this one, not that much needed. Okay. Next, moving forward, these examples you have to solve. Then coming to electrolytic cell, definition of electrolytic cell is important, so please learn this definition, okay. Then here we have something, application of electrolysis, how pure copper is obtained, that can be a question, okay. Next, sodium and magnesium metals are produced by the electrolysis of their fused chlorides, and aluminum is produced by the electrolysis of aluminum oxide, okay. So sodium and magnesium is obtained from the chloride, aluminum is oxide obtained from aluminum oxide in presence of cryolite. Okay. Okay. Next, coming to the quantitative aspects of electrolysis. So here we have, okay. So here we have first law and second law. So you need to learn the statements of first law and second law. Okay. Then we have something here, that is the formula. I think formula, I am not saying that it is means you, one second students. Okay. So formula is like something which you should be knowing. So I am not telling that you know this formula. So make a formula sheet, that is different. This video is just to tell you the theory part which can be asked in the exam from the book, different corners that can be asked. So that is why this is there, okay. Next we have, let's move forward, yeah. So what is Faraday? The quantity of electricity, how much is Faraday? 1 mole of electrons is Faraday, that is given here. Next year you should be knowing like 1 mole of Mg2 plus requires 2 moles, aluminum requires 3 Faraday, okay, that is also very common. Question answer, we solve many of this one. Next, product of electrolysis depends on what factor? So here also depends on the nature of the material being electrolyzed and the type of electrodes being used, okay. So till now we have so many factors. The first one is where conductivity depends, then ionic conductance depends on what, metallic conductance depends on what, products of electrolysis depends on what. So these all factors you should make one chart and write down, okay. Fine. Next we have something here, that is it also, so 2 factors we studied here and this is the third factor, okay, that is there. Next, something we have called as overpotential. So what is overpotential? You should be knowing. So definition is given here. Next, these are the products of electrolysis that definitely you have to study, okay. Now here one interesting thing is there, okay. So at anode, if you see the reduction potentials are given, right. So reduction potential of H2O is what I'll say, reduction potential of H2O is less, that means it should undergo oxidation, but actually chlorine undergoes oxidation. That is because of what? That is because of the over potential of oxygen, okay. This can be a very good tricky question or very tough paper can ask this question, so you should be prepared for this one, okay. Next you have electrolysis of sulfuric acid, the equations you should be knowing, okay. Next we have okay, these are for concentrated and for weak, like dilute sulfuric acid, the products of electrolysis are given, okay. Now we have batteries, the last part, right. So in batteries what you have to do, it is my suggestion, make a table, okay, write down headings like anode, cathode and electrolyte and cell potential, okay, anode, cathode, electrolyte and cell potential. So for everything I have given you, for example, first is what is primary battery, then in zinc cell, where like which is where it is used, you should be knowing the uses. Then you can know like anode is your zinc container, cathode is carbon rod, right, surrounded by manganese dioxide and carbon, ammonium chloride and zinc chloride are the electrolytes, okay. This is there. Anode and cathode reactions you should be knowing, okay. Next, coming to mercury cell, where it is used, anode, then which is used as anode, which is used as cathode, these all things you should be knowing, and the electrolyte that is used, Okay, next we have here something is called as your cell potential of mercury cell is given. Similarly, the cell potential of the previous cell was also given 1.5 volt. Okay, this time in MCQ the cell potential was asked, so be very careful and note down these values. Okay, clear. Next we have the next shell, that is your secondary cell. So in secondary cell, what is secondary cell you should be knowing. Okay, then in lead storage battery, which is the anode, which is the cathode, and which is the electrolyte. Okay, next lead cell reactions you must remember, definitely you should remember this one, this is very very important. Okay, so here I will write, I have not highlighted it. Okay, so let me see if I can. Okay, 1 second. Okay, sorry. Okay, it's not working. Let me underline just this one. Okay, so this is very very important, so make sure that you learn these two reactions. Okay, next we have this one. This diagrams and all not needed. Okay, diagrams you no need to read. Fine. Next we have nickel cadmium cell. Okay, so you can write down what is the limitation of nickel cadmium cell. So that is that generally they have longer life, but they are more expensive, right? So this is the advantage and the disadvantage. Okay, next nickel cadmium reaction is given, that you should be knowing. Then you should go for what is fuel cells. Okay, so definition of fuel cells is there, that is important. Next you have example hydrogen fuel cell, where it was used Apollo space program. How was it used in Apollo space program, that is required. Then the construction of fuel cell, this is also very very important. Okay, so this is what construction of fuel cell. So if a question is asked directly like this or something related to fuel cell, you need to write this part. Okay, construction of fuel cell. Then fine, let's move forward. These reactions are also damn important. Okay, very very important, these two reactions, so please do not miss them. Okay, very important. Overall reaction is also very very important. Okay, now coming to efficiency of fuel cells, 70% more than the normal cell. Okay, okay, fine. Next, moving okay, next we don't have anything here. Okay, next is about rusting. Okay, but mechanism of rusting is very important. Again, a question can be asked from here. This whole paragraph is regarding what? Mechanism of rusting. Okay, this all is mechanism of rusting. Okay, mechanism of rusting, that you should be knowing, and write down this answer again and again and prepare it. Okay, next what we have here is, yeah, this all is then is prevention of rusting. Okay, some methods are given here for prevention, so you can learn these methods. Okay, some 2 to 3 methods are there, these are important. Okay, so that's all. Then in text question, hydrogen economy, you can just read this paragraph, not very important. Okay, that's all in this chapter, students. So yes, that's all, and these all are the things that you should be highlighting. I told you how the questions can be asked, so write down the questions, write down the answers is point, and keep a note, like just give a heading like electrochemistry NCERT questions. So because the chapters are less in chemistry, so it is a high probability that questions will be little on the tougher side maybe, so we need to be prepared for the worst conditions. So these are the questions that can be extracted from the book and can be asked to you. Okay, so if you are done with these questions, the Brahmastra questions, and you have learned the formulas, practice the numericals, then this chapter is done for you. Okay, so I hope you have liked this video and you have underlined everything, and you are having any other doubts, so please comment down, I'll definitely address. If you did not, so whichever things I have highlighted, so go through it, read those part. If you did not understand anything, please comment down, I will definitely explain to you. Okay, so that's all, students, and see you soon in the next episode of Decode NCERT. And please let us know, how is this session going on? Is it really helping you, or how can we modify it so that it will be more beneficial for you? Do let us know in the comment section. We will definitely act according to your feedback. Thank you, students, and see you soon. Do not forget to subscribe the channel.